Okay, hello everyone. Thank you, Carl, for inviting me again. Let me start spending a couple of words on myself. I've been a developer for about 40 years and a VBA developer for about 25 years. I had the chance to consult for the United Nations for several years, which brought me to work in nice countries such as Italy and Austria, but also in amazing places like Afghanistan, Pyongyang, North Korea, and Ethiopia. In 2014, I moved to Frankfurt, Germany, where I worked 5 years for the European Central Bank and where I still live with my family. Last year, as some of you probably remember, I presented my dynamic interfaces, as I like to call them, but today I'm going to talk about much simpler things. As some of you may know, in the last year I've been publishing what I call VBA pills, that's to say, extremely short access tricks and tips, and here today I'm going to show you a short selection of these pills. None of them is extremely new or revolutionary, but I hope they can be of some interest. Let's immediately start with the biggest form, hardware info. Name of the computer, manufacturer, model, processor, and a large amount of other information, including monitor resolution and available memory. There's nothing really original here. The code is mostly taken from the Microsoft website at the address you see here below. API-wise, it only uses two functions to get the available drives. All the remaining information is collected using Windows Management Instrumentation, or WMI, which is a Windows built-in infrastructure for data and operation management. The next generation is called Windows MI for management infrastructure. It's already available and is described as easier to use, and I do hope it is. WMI can be used to get data or to automate admin tasks by means of scripts on local or remote computers. You can write scripts in VBA, C++, C Sharp, VBScript, .NET, J Sharp, and other languages. You connect to a WMI object using the getObject function with what is known as a moniker, a string which always uses the credentials of the currently logged on user. Sometimes an impersonation level is necessary to determine how much security a process must have to access a client application process. A moniker is composed by the mandatory prefix WinMGMTS and two optional components, a security setting and a WMI object path. But I will not pretend I'm an expert of this stuff. I'm still studying this topic, so I won't go into further detail. Daniel Pinault recently published a WMI viewer on his website, so probably he's much more knowledgeable than me on this subject. As a side note, some people report of problems encountered with WMI, especially while they are signed in with Azure Active Directory, but I never tried, so I can tell anything about this. Anyway, the interesting thing is that once you establish a connection to this WMI component called CIMV2, you can query its tables. For example, Win32 computer system, which holds information on the local machine, or Win32 processor, Win32 physical memory, rather self-explanatory names. There are other methods like these instances of, but again, I don't know enough to go into any more detail. The only original thing here is this monitor ratio, which is not provided by any API, so I developed a small function to transform a decimal number into a fraction. It's rather empirical, but it seems to work. This is just a fraction of the information that can be retrieved. Recently, Jason Lee Hayes published this image on a Facebook group. Not only is it way better looking than my pill, but it also shows a ton of additional information. Let's move forward with a classic. Find the executable application for any file. Windows associates file extensions to executables, so it knows that a TXT is opened by Notepad and ACCDB is opened by Access and so on. So we can select a file, the code finds the executable, and you get the choice to open it maximized, minimized. I won't do it now. It will open in the Windows taskbar, or normal. Note that these three options don't always work. It depends on the executable. It's also possible to print the file to the current printer, in this case a PDF virtual printer, or to open the printer setting panel to choose printer and printing options. The executable is determined by using the API function findExecutable. Launching the application is done using a standard shell command, and a shell execute is used to print a document. There are some relevant differences between shell and shell execute. Shell is a VBA method. Shell execute is an API function. Shell execute can open any file with its default application. With shell, you must provide the executable application explicitly. Shell execute can print a file. I'm not sure whether shell can do that. And behind the scenes, shell is a thin wrapper around a winexec call, while shell execute is a fat wrapper which goes through multiple function calls. This is what happens when you run a shell execute call. As you can see, it goes through several layers of modules and functions until it reaches the kernel and then goes all the way back to the top to return the result of the call. This makes it kind of slower compared to a VBA shell function. Shell execute is more powerful. You can connect to a web page. Let me set a breakpoint here so we can access shell execute. Shell execute 0 VB null string, the address we want to open, VB null string, and say normal focus. And here it is. Or we can even start an email, for example. So shell execute, we have to pass this form handle, then open, and the mail address we want to write to. And again, VB null string, and again, normal focus. And here we go. So shell execute is definitely more powerful than shell, but shell is thinner, is lighter, so to say. So nothing really extraordinary here as well, but still it may be useful. The next is a very quick one. It just opens the Windows magnifier and you can zoom in up to 1600%. Frankly speaking, I have no idea why someone would need to do such a disturbing thing, but we all know that users are strange. Code-wise, there's not much to say. We have the shell execute again. Of course, this may fail when the magnifier is not found in the standard Windows folder, but that's another story. Borderless forms. Obviously, a borderless form has no title bar, so moving it seems impossible, and that's probably why borderless windows are used. But in some cases, moving it may be necessary. There's more than one solution to this problem, but they often use API functions, which is something I prefer to avoid when possible. What I do in this case is using send keys, which I usually tend to avoid more than APIs because its behavior is rather erratic and unpredictable, but in a case like this, it seems to work quite fine. Actually, a single send keys would be enough, but you never know what's on the form and where the cursor is, and what can happen when you send a key to the form. So it's good practice to send another key to at least try to compensate the previous one. This is a nice one, screenshot. It takes a snapshot of the active window only, not of the whole screen. So you have to select the target folder for the bitmap that will be generated. Let's open the Explorer window so we can see what happens. Now, when I click, the shot is not taken immediately. There is a slight delay allowing me to select the window I want to shoot, so to make it active. Otherwise, the access window would be taken. So I click and immediately activate the target window. And here it is. I made a class for this function that can be easily imported in any project. It's basically an exhibition of API functions, mainly dealing with the clipboard. The actual screenshot is done simulating a sequence of keyboard events. Once imported, the class is easy to use, the instance of the class is created, and the two methods getScreenshot and saveClipboard are called, so very easy. Here's another funny one. It uses subform to project the webcam image. I can start the webcam, and here I am. I can take a snapshot, and here it is. I can even change some settings, for example, the size of the webcam. And I can stop the webcam. The nice thing is that the whole process is handled by only two API functions. Once the subform has been hooked to the internal process, everything else is done via a normal send message. If you look at the snapshot code, that's a completely different set of calls compared to the screenshot we saw before. And that's because in that case, any active window could be selected even out of the access container window. In this case, we know exactly which window is the target and it's within access. Even more, it's within the active form, so we can use send message. Other commands as well are invoked sending a message to the capture window. WhatsApp. How to send a message with WhatsApp. Unfortunately, the WhatsApp client app must be properly installed on the computer. Now I have it, but I will not open it. Last year my presentation caused some issues and a lot of extra editing work for Carl because I naively showed some information that someone deemed confidential. This time I'll try to be smarter, so I prepared a short clip with blurred areas on any data that can possibly be perceived as sensitive. As you can see, you just enter the telephone number, write a small message, and hit send. On the first execution, this window pops up asking for the user permission to access WhatsApp. You can uncheck this option here to prevent this window from appearing again. Go ahead, and after a few seconds, the message appears on the recipient's WhatsApp. How is it done? By creating an instance of a web browser, opening WhatsApp, passing the text, and clicking enter with the send keys, unfortunately. But again, in this case, it seems to work every time. The only problem is the computer performance, so some delay is needed before virtually pressing the enter key, and this may depend on the specific machine. Please do not ask me how to send images or documents or how to send your spam messages to multiple recipients because I haven't found a way yet without using third-party solutions like Selenium, and I'm starting to believe it's not possible at all. But if you find a way, please let me know. And now for something totally different. A common task when we have records is detecting and deleting possible duplicates. There are several ways to accomplish this result, but the one I prefer is an easy SQL query. As you can see, we have one duplicate here. Mr. Sulu from the West Zone appears twice. I want to get rid of the second record. The solution I prefer is this query here. First, it groups the records on every field. Then it gets the set of the first ID for each group, so basically it selects one record per group. And finally, it deletes all the records with different IDs. So I expect this record here to disappear, and that's it. What about the performance on huge sets of records? I don't think it should be a big problem. Maybe those of you with more experience on query performances can discuss this topic better than me. I've been using this query for years now, also on rather populated record sets, more than 1 million records, and I never had to wait for too long. After all, this is meant to be a periodic maintenance operation, so if I have to wait for a few seconds every week or month, I think it's acceptable. Nothing to say on the code, it just executes the query. This one may be more interesting. In many cases, it's useful to know the next ID that will be automatically generated by Access as primary key in a table before it's actually generated. I have this table here with a dummy record whose ID is 1, as this text box says. When I press the button, I know that the next record will be 2. As you can see, no new record has been added, and so far so good. You may say, okay, just add 1 to the last ID, but obviously not that simple. So let's say I add a couple of records, item 2, item 3, and then I delete them. We all know that the next ID will be 4, and the code knows as well. To find the primary key field, I scan the table indexes looking for a field with a primary index associated. That's what this function does. If such a field is found, it returns its name. The next thing to do after finding this field is to query the ADOCS catalog, so I create the object with a proper connection and request the so-called seed property for the primary field of the table, which I found before. This is the value that Access will use as next ID. As you probably know, ADOCS is a catalog containing collections describing the schema of a data source, tables, views, users, and so on, groups, procedures, and such. You can early bind it linking this library here. Let's move on with another useful function, which reads all the files in a folder, storing their names in an array. To make it a bit more interesting, I also added the possibility to recur subfolders and to select specific files based on their names. To see it in action, I prepared this dummy folder with random files taken from some Windows system folder. I hope there's no sensitive data. So when I click the button, only the root is read. Checking recurred subfolders, the recursion is activated and the whole branch is read. If I want only the log files, for example, I use the mask star.log and I only have the logs. The main code is made up of 2 functions, but the first one, folder read, just launches the second, do read, which is the real core function which performs the recursion. Nothing really revolutionary. I use the dir function to select all the relevant files according to the mask and put their names in an array. If recursion is required, then I use the file system object to navigate through the subfolders and recursively call the same function again on each of them, passing the array as a parameter so that new files are added to it. Folder final slash is just a simple function making sure that the folder name ends with a backslash so that the dir call can properly work. As you can see, the longer paths are shortened so that they remain within the list because their full name is too long to be shown. And this is our next build. And that's the first totally original thing we see today, meaning that this is something I made myself, not derived from a web snippet found somewhere. So we select a long path. I prepared a test long path here. And being too long, it floods out of the text box. We can cut it in the center. Maybe 90 is okay as well, right there. Or we can cut it to the left if we want to focus on the right final part of the path, which usually is the most significant. Note that the 2 options use slightly different algorithms, so they may have different size requirements. For example, we saw that 90 is perfect for a center cut, but it's too much for a left cut. If the size is too small, the whole string gracefully collapses to a single ellipsis. How is it done? Well, going into detail would take too long. I'll just sketch the basic idea, which is extremely simple. Basically, the string is split into its components based on the backslash. Then, supposing we are cutting in the middle, the center component is replaced by the replacing characters, which by default are 3 dots. The length of the string is checked, and if it's less than the user's threshold, the procedure ends and this string is returned. Otherwise, this part of the string is deleted and another substitution takes place. So the string shrinks until its length matches the user's requirement, and in the resulting string, the surviving subfolder names remain untouched. Next one, let's talk a bit about zipped files. Sometimes it's useful to know how many files there are in a zipped file. So we select the file. Let's say we want to count both folders and files. Run it, and we have 0 folders and 593 files. Let's check. (593). Let's try the second one. 3 folders and 412 files. Let's check again. 2 plus 1 plus 409, that's 412. We can select specific extensions we are interested in, for example, say FTB and CFG. And in this case, we have 3 files as we didn't count the 409 JPEGs. In the code, folders and files are counted separately, even though the code is the same, but when we count the files, we pass the extensions. To handle a zip file, we create a shell object and open the file as a namespace. The important thing to note here is that the file name must end with a backslash as if it was a folder, and that's because Windows does consider a zip file as a folder. DoZipCount is a recursive function which does the actual counting. It reads every item within the file. If it's of the requested type, for example folder, and it has to be counted, a counter is incremented. Then the function recursively calls itself, passing the current folder as a namespace. For the files, it's basically the same. We count them if the extension is correct, but there is no recursive call. Note that if the zip file contains another zip file, this will be counted both as a folder and as a file, but if this is not the intended behavior, it's easy to add an if to this code or to provide a list of extensions to be excluded. Let's stay with the zip files a bit longer and let's see how we can zip and unzip a set of files. This is a totally original VBA peel. It's not yet published on my website. I will do that in the next days, hopefully. To start, we'll zip some files. Select the source folder and the target folder. We can also choose to recurse subfolders and to set a file name mask to zip only specific files. To make it short, I just allow one single mask here, but in case we can make some changes to the code to allow for multiple masks, something similar to what I did in the previous build with the extensions. There are 3 folders with some random files, the same we saw before. So we click on Read Files to preview the files that will be zipped. The list is not editable, but some code may be added to delete unwanted files or to add extra files. The file will be created here, so we click on Zip Files. And the file is built. Unzip works the same way. We select the zip file, in this case the same I just created, and the destination folder, which is currently empty. This one. We can preview the files contained in the zip, and again we could add extra code to delete unwanted files. We run it, and after a few seconds we find our files in the selected folder. Zip first. The first part is not different from what we saw previously. The same recursive functions are used to read the source folder. The interesting part is in the run button code. One thing I didn't mention before is that when we use the shell namespace, all parameters must be variant, and that's why here I cast the strings I need to local variant variables. This is the part that is keeping me from publishing this code. All the selected files are copied to a temporary folder, which is a costly operation. That's because it's easy to use the namespace to zip a whole folder, but I haven't found an efficient method to add a single file to an archive. Yet, I'm still experimenting in my spare time. Anyway, once all the files have been copied to the temporary folder, an empty zip file is created. It's just a normal text file with a zip extension and a specific sequence of bytes at its beginning. There's a capital P, then a capital K, a couple of non-printable characters, and 18 zeros in a row. That's enough for Windows to understand that this is a zipped archive. Finally, we create the shell object and use its namespace property to copy the whole temporary folder into this file. The temporary folder should be deleted, but it can't be done before the process ends. So I added this empty loop waiting for the number of the zip files to be equal to the number of the selected files. When they are the same, the process is done and the folder can be deleted. The unzip part is much simpler. I still cast the strings I need to variant, create the shell object, and use its namespace copyHere method again to extract the files from the zip and put them in the selected folder. And that's it. Still a couple to go. In this form, I gathered a couple of quick things that can be really demonstrated during this presentation, but I think they're good to know anyway. The well-known lock function to lock the workstation. It's quite common, but hopefully some of you don't know it yet. Of course, I'm not pressing the button now. A list of the users connected to this database. There's only me now, but in case the database is shared, such as a backend, there might be more than one. And the current decimal point, which depends on the international settings of your machine. I have English set, so the decimal point is a dot. If I had Italian, this would show a comma. So let's test it. I select Italian, refresh, and here we have a comma. The code to lock the workstation is immediate. It's just a simple API call, not much to say. The get users is more complicated. I adapted an old snippet I found on the web, and to be honest, I don't understand it thoroughly. It has something to do with some property of the jet engine, which uses this GUID to extract the list of current users. Fair enough. This open schema call returns a record set with 4 fields. The first is the computer name. The second is the login name of the user. The third is a flag stating if the user is still connected to the database, and that's because a user's ID remains in the locked database until the last user disconnects. So if their names appear in the record set, it doesn't mean they are still active. And finally, another flag called suspect state, which tells if the connection was terminated under normal circumstances. I'm rather sure it's quite common for SQL Server databases, but I'm not totally sure this applies to Access as well. Anyway, the code just collects these pieces of information in an array and returns it to the caller function. In this case, the array items are simply dumped into the list box. Finally, the decimal separator. There are several ways to determine it, for example, reading the registry or using some API functions to access the current international settings, but I wanted an easier method, so I thought of this one. I convert a string with a comma separator to a single. If the resulting value is the single I was expecting, then the separator is correct, else it's not. Quite fast and simple, and so far it has worked pretty well. Maybe here I discovered the hot water, as we say in Italy, meaning it's an absolutely common thing that everybody knows, but I didn't spend too much time searching the internet about this topic. Last thing for today, press keys can be detected. Initially, I was going to use several toggle buttons to show this interaction, but eventually I thought that would be too ugly to see and too boring to watch, so I created this virtual keyboard. Any key I press is detected and shown on the keyboard. For example, Shift, Control, Alt, Space, Numlock is already on, Caps Lock, Backspace, Esc, but also the function keys, the numeric pad keys, and any other key is detectable. This relies on a few API functions, but also on some binary arithmetic like the check for these keys here. The keys can also be set via code, thereby simulating a user action. Numlock, scroll lock, caps lock, and so on. And this is the list of the keys that can be controlled by these functions. I didn't check all of these codes, it's not really a priority, and that's why these are commented out. If you're curious to know how I made this keyboard, well, there's no rocket science here. It's just the image of a keyboard used as a base and several images I created with Photoshop used as overlays whose visibility is controlled by the code. Creating all these images was quite boring, but other than that, there's nothing really relevant to highlight. Some side notes on the sliding door effect I used in this presentation. Those of you who are kind enough to follow me on my website or my YouTube channel know that years ago I developed this drag and drop engine for access objects such as images, command buttons, text boxes, and labels. This is a variation of that technique. As you can see here, I'm dragging command buttons which are adjacent to one or two subforms. Initially, I thought it would be easier since the movement is restricted to the horizontal axis only. There's no vertical movement. But it turned out to be harder, really. That's because in the normal drag and drop, the movement is only limited by the four boundaries, and all the objects are independent, while here the movement may also be limited by the previous and or the next command button, if they exist. So these objects are not independent anymore. And this had a relevant impact on the original code. I recently published a video on my VBA shop explaining in detail how this effect is made, starting from scratch as I usually do. So if you are interested, you can find it in the workshop section of my shop. So that's it. I'm conscious I haven't shown anything innovative today. Actually, my first idea was to show you something more technical. That's to say, what I call the master-slave class technique, which is what I mainly use to make my graphical interfaces, essentially a way to handle arrays of objects with events. But then I thought that would be too technical, too abstract, so I opted for something more practical. Probably the most original thing here is the function to transform a decimal number into a fraction. But in the past I found many of these snippets to be of some use, so I thought it would be nice to share them with you anyway. Hopefully some of you will find some of them useful as well. If you're interested, you can download them all, for free of course, from my VBA shop. And that's really all, so thanks for your attention.